Dan apakah video saya terlihat? Boleh tolong ditulis di kolom chat. Oke, terima kasih Theodora sudah menjawab. Baik, saya akan berbicara dalam bahasa Inggris saja ya, karena speaker kita hari ini merupakan student dari Maastricht yang tidak berbicara bahasa Indonesia. Juga kita ada kedatangan 2 speaker gitu, jadi kita akan dalam bahasa Inggris saja. Baik, good afternoon everyone. Warm welcome to this event, Study in Holland online di rumah aja series. So allow me to introduce myself. My name is Is Mutating as the student counselor for Nufik Neso Indonesia. I'm here with my colleague Muhammad Maulana Taufik as the education promotion officer. So if you have any questions related to study in Holland or scholarships that we organize or we manage, you can always write your questions in the chat box, and we will help you with that question. So anyway, for those who are joining us the first time, we organize this event regularly every Wednesday and Friday, where we have online learning, interactive seminar, and Holland alumni lecture. So as you may already aware that in today's online learning, we have a lecture from Maastricht University. The lecture will be delivered by Mr. Kingson Junsheng Thang Luc. He is a student assistant, a third-year student in Biomedical Sciences and first-year student in European Law at Maastricht University. The topic that he will be presenting is a bird's eye view of SARS-Cov-2 coronavirus and COVID-19. So in his presentation, Kingson will share with you more details on genetics and viruses, antigenic shift and antigenic drive, what is coronavirus, obviously, transmission, infection, and viral replication, and COVID-19 diseases course, diagnosis and testing, and lastly, measures and prevention. He is here also accompanied by Miss Lian Kroll as the country team Southeast Asia from Maastricht University as well. So before I move forward to read a brief biography about our speaker, I will be giving you a brief information about Nufik Neso. All right. So first of all, about Nufik Neso. Nufik is a Dutch non-profit organization from based in The Hague, the Netherlands. We are an organization that supports internationalization in the field of education, and we are funded by the Dutch government. Nufik Neso itself is a short for Netherlands Education Support Office, and we have currently 10 representative offices in 10 different countries. That includes Indonesia, China, India, Mexico, South Africa, South Korea, Turkey, Vietnam, Russia, Mexico. So there are a couple of key activities that we do. The first one is we provide you study in Holland information. We also do student counseling for prospective Indonesian students. We promote cooperation between higher education institutions. We also act as a key facilitator for supporting Holland Alumni Network, focusing on the alumni in Indonesia, of course. We also manage some scholarship programs, including StuNet. That is a program for master program and tailor-made training. And then we have Orange Knowledge Program for tailor-made training and institutional collaboration. And then we have Orange Tulip Scholarship, that's scholarship for bachelor and master programs. And lastly, we have EU Share, scholarships for intra-ASEAN mobility. And lastly, as Nuvikneso, we also facilitate scientific research collaboration between Indonesia and the Netherlands. So if you have further questions about studying in Holland, or you would like to know more about us, you can visit our website at www.nesoindonesia.org.id, or also visit our social media channels, and you can always contact us via the email stated there, or WhatsApp, and our cell phone number. Other than that, we also organize a online counseling via Zoom. So this is to shift our counseling through via face-to-face. So you can always do this counseling every Monday to Thursday, in which we have it in the afternoon session on Monday and Tuesday, and for Wednesday and Thursday we have morning session. So you can just visit bit.ly/Oceani so to know more about the counseling session. So that's about my presentation. Before we get into the main event, the main program for this event, I would like to read some descriptions of our speaker for today. So as I've mentioned, our guest speaker is Kingson. Kingson has a background in Chinese, Vietnamese, Australian, and European, which gives him a broad perspective of the Oriental and Occidental world. As a student pursuing a bachelor's degrees in biomedical sciences and European comparative law at Maastricht University, Kingson is also a marketing and recruitment student assistant for the China and Southeast Asia Marketing and Communication Department at the university. So prior to that, he also has involved in United Nations Economic Commission for Africa as international delegate. From an early age, curiosity has fueled his interest in the sciences and the world. So asking an unanswerable science-related question was his number one skill in kindergarten, primary, and secondary school. So his curiosity has driven him to reach out for every new opportunity to learn and get the best out of his education. So that's about his biography. So now I would like to welcome you, Kingson and Miss Lane, to the floor. Hi, good morning, Lian and Kingson.
Yes.
How are you?
Thank you for the introduction, Amy. So my name is Lianne Kool. I work at Maastricht University. And before we go in depth into Kingson's presentation, let me very briefly give you a short introduction about our university. So let me see. I will keep it very brief because I think Kingson's presentation is something we're all looking forward to. But I'm not sure how familiar everybody is with our university, but Maastricht University is the youngest university of the Netherlands. We were founded in the mid-70s, but at the same time, we also rank highly as a young university in the world. According to the Times Higher Education rankings from this year, we are the 6th best. And two other important points is that, like Kingson, we have many international students in the Netherlands and also at the university. And we're also European founder of problem-based learning. This is a student-centered method, which means that instead of listening to lectures all the time, we focus on getting you actively involved and engaged with your learning materials and search for knowledge yourself. And as Kingson will show, I think it works very well in, on the one hand, developing yourself, but also in retaining the knowledge that you learn. And we also call ourselves the most international university in the Netherlands. Over 50% of our students are coming from abroad. These are lots of European students, of course, from Italy, Germany, or Belgium. But there's also a sizable population from outside of Europe, especially from Asia. There's many different nationalities represented, and of course, Indonesia as well. And not only our students have many are coming from abroad, but we also have lots of foreign academic staff working at our university. And in total, there's definitely over 100 nationalities, which gives you a very international perspective when coming to us. You can't see it very clearly here, but we are located right at the heart of Europe. So from our university, you can travel to Brussels, to Paris, London, or Berlin once everything is back to normal again, all within a couple of hours. So we work together actively as well with European partners, and even outside of Europe. So there's many opportunities as well to study abroad or do an exchange or to do an internship abroad. In some programs, it's even mandatory. So we really fuel such a broad perspective for our students as well. And of course, I'm not sure if some of you may be able to speak some Dutch, but almost all of our bachelor studies are fully in English. So we welcome you, of course, to learn Dutch if you want to, but it's definitely not necessary. We really value this kind of environment, and I think it's a very different atmosphere in Maastricht as compared to some other Dutch cities, because we're an old city, but an international city as well. If you want to know more, feel free to always check out our website, our social media. We will have our open day for bachelor programs on the 6th of February and for masters on the 6th of March. So be sure to check out those events and get in touch if you have any questions. And we hope to see, and if you are interested, then we hope to see you in Maastricht someday. So that's my part for this moment. I think we are all now fully excited for Kingson's lecture. So I will tune out for now and give the floor to Kingson.
Okay, thank you, Leanne. So I will briefly share my screen and we can crack on to the presentation. Okay, just give me a second. Okay, there you go. So good afternoon, everyone in Indonesia or wherever you are. And this is my presentation about COVID-19 or SARS-CoV-2. Just a quick disclaimer: this presentation does not provide medical advice, nor is it intended to do. If you have a disease or if you have any problems, please call your doctor or contact a professional, or if there's an emergency, call 911. So my name is Kingson Luc. I'm a student in biomedical sciences and also a student at the European Law School, and I'm the student assistant for China and Southeast Asia. So if you happen to come to our university and you have any problems, you can always contact me. So I'm going to briefly talk about the basics. What is coronavirus? Because you get a lot of information these days, right? And a lot of people there's a lot of misconceptions and everything. So I want to put it straight in one presentation so everyone is on the same page. I'm going to talk about the diagnosis and testing and measures and prevention, of course. And of course, there's maybe some additional materials as well. So as you may have heard, we are in a pandemic right now. and this pandemic started in China and it spread all over the world. What is important to mention is that COVID-19 and SARS-CoV-2 or coronavirus, these nomenclature or these names often get mixed up. So the disease with all the breathing problems is called COVID-19, whereas the virus and the infection with the virus itself is called SARS-CoV-2 or severe acute respiratory syndrome coronavirus 2 or coronavirus just in short. So what is important to remember is that some people, they already don't understand the differences between viruses and bacteria. And I think that's a very essential thing to understand already, because when we talk about bacteria, as you can see on the left, we see their structure, they look quite different than viruses, right? And this is why, for example, antibiotic drugs only work on bacteria, not on viruses. And viruses are much smaller, as you can see. Viruses, some viruses even infect bacteria. Here you can see phages on the right in green. In green, those are the viruses. In blue, that's the bacterium. As you see, the bacterium is much bigger than the virus itself. And this is also why antibiotics don't work, because they have different structures. So now we are on the same page about viruses and bacteria. We can move on to the next part. Genetics. I'm not sure about whether anyone has biology, but I'm going to briefly explain about genetics as well. So as we know, every living being, including plants, humans, has a genetic code, which is more or less some kind of building plan, what you're made of, how it is built, what your color of your eyes is. Even viruses and bacteria have this. So in humans, we have DNA. And this DNA contains the genetic instructions of our body. And this is transcribed by our body into RNA, and then it's made into protein. And the proteins, they form your organs, your skin, your eyes, everything in your body. So let's go back to the DNA structures. As we have seen on the right, on the left, we see a double helix structure over here, which is the DNA. And on the right, on the left, we see RNA. So some viruses, they have RNA, and some viruses, they have DNA. And they enter our cells and they more or less hijack the machinery and let them copy themselves. And that's definitely not what we want, right? So moving on. There's a lot of viruses, I said. There's DNA viruses and RNA viruses. And as you see in this table, we see that coronavirus belongs to the plus RNA viruses. What does that mean? For now, that's not important. All you need to remember is that plus RNA viruses, they can enter the body without any transcription or any additional steps. So they can immediately hijack the cell and start telling the cell, you have to copy me. So what is also remarkable to mention is that viruses, they are not living beings. The reason is that they always need something or some cell or some host to replicate themselves. And that's why they are not living. That's a little bit weird, but just take it for now. So as we see here, we see the virus entering a cell. We see that on the left, we see ACE2. ACE2 are more or less the keys for the cell. So ACE2 is normally used for hormones of blood pressure in your own body. But this virus hijacks this cell more or less. And this cell has a lot of spikes, as you see. And these spikes are more or less the keys to open up the cell and to come in. So when this virus binds to these receptors or keyholes, the cell opens and let the virus in. And this virus is going to deassemble himself and put its RNA into the machinery of the cell, and it's going to replicate themselves. And afterwards, these viruses, they get replicated and exit the cell and start to infect other cells. As you see in the figure as well, we see here remdesivir, hydrochloroquine. Those are drugs which more or less block the replication of the virus. And that's also important to remember. I will come back on that later. So on the right here, we see a one-step growth curve. What is that? So you may have heard that if you're infected with coronavirus, it takes more 10 to 14 days for the onset of the disease. And the reason is that when you got infected, you don't immediately start show symptoms. The virus has to enter the cell, has to replicate itself, and the viral load has to be high enough for you to show symptoms in your immune system, of course. So we see here that there's a latent period. And this is why if you are infected with coronavirus within these 10 to 14-day period, and you are going to conduct a PCR test or any test, you won't detect anything because the virus is still in the cells, busy with replicating themselves, and the concentration of the virus is too low. And that's why we're in the latent period on the right, before they exit the cell and start to go outside the cell, and then you got a lot of other problems. So I hope you're still with me with the replication of viruses and genetics. Okay, so moving on, as I said, there's a keyhole on the left. You don't need to remember what that is. So on the left, we see the keyhole, so more or less the key of the virus to enter the cell. So there's some normal step. You have on the right, you see recognition of the virus, attachment, and you have penetration and uncoating. And afterwards, the virus just opens itself up and throws its RNA out, or DNA, depends on the virus, and hijacks the cell. Afterwards, after hijacking, sometimes the cell is going to copy the virus so much that the cell even lyses. So it's like a balloon. It just opens up and splashes out other viruses, and the cell dies. What is also important to remember is that the virus, when it replicates itself, it also replicates the spike proteins. So these keys on the left, and you see that these keys also of the virus are displayed outside the cell. So the keys of the virus are displayed outside of cells. So the immune system can recognize these cells. So when the immune system recognizes these keys of the virus or spike proteins, the immune system knows that it has to kill that cell to get rid of the replication process. So that's quite smart. We'll come back on that later, actually, for vaccines. So stay tuned. So what is coronavirus actually? We see that there's so many coronavirus types actually. And in the beginning, many countries over the world, they thought it was a simple flu. And why was that actually? So normally, flu viruses, they are most of the time alpha coronaviruses, and there's a misconception over there. Alpha coronaviruses most of the time are flu viruses, and that's true. But on the right, we see that SARS-CoV-2, what they did not know in the first place in the beginning, belongs to the beta coronaviruses, which is a completely different strain and much more infectious. We see that MERS, Middle East Respiratory Syndrome, or MERS-CoV is also in there, and severe respiratory syndrome, the first respiratory syndrome, which started in Hong Kong, if I'm not sure, is also in there. So we see that this virus, the beta coronavirus, infects a wider range of organisms. We see they infect mice, bats, humans. We see poultry, such as cows and pigs, horses, dogs, and even some small rodents. So some small rodents, which is quite important to know as well, because if a virus which normally does not infect humans and another virus which infects humans enter a cell of, for example, an animal cell such as pigs or pangolins, as we saw in coronavirus, or bats, enters the cell at the same time, as we saw, they replicate their DNA, but their RNA. Sometimes these viruses, they accidentally combine themselves. So it's like putting everything in a cake bowl, and you're going to just swish around, and you get a new kind of virus. And that is quite dangerous, because these viruses have never infected humans before, and this can lead to big pandemics as well. And this is what happened with coronavirus, and this is a completely normal process. It has happened in the human world over thousands of years, when we started to live with animals or close to animals. So what is mutations? You may have heard of mutations before, of viruses on the right side of this picture. So that is accumulation of mutations over time. And what is that? So most of the time, when a virus enters the cell and it copies itself, sometimes the cell makes a small mistake, and this mistake leads to some changes in the virus. For example, the keys, they completely differ. They will change completely, or they change a little bit, but they're still recognizable by the immune system. But over time, this will cause a problem. And this is why influenza, for example, or the flu, the ordinary flu, mutates every year. And this is why some people need to get vaccinated for that, especially people with weak immune systems or compromised immune systems. So what is important for takeaway is that coronavirus probably was caused by antigenic shift. So two viruses combining in an animal cell accidentally start becoming a new virus, and this has led to the pandemic. Okay, so we see that SARS-CoV-2 probably originated from bats, and then and the reservoir, the intermediate host, was probably a pangolin, as you see here, and then it jumped over to humans. It says a mortality rate of 3%, but this data is a little bit outdated, so of course this may be a little bit higher now. We don't know yet. Okay, so what is coronavirus? Corona actually means crown. So why does it mean crown? If you look at the virus under an electron microscope, you will see it looks indeed like a crown. That's where it got its name from, because of these spikes, as you see here. So we see the virus on a schematic structure of the virus on the right, and we see that it has RNA as well, as I said earlier, and it's enveloped. You don't need to know what that means. As you see here, it has a membrane, and it has these keys, as I said, to enter the cell, these spike proteins. And these spike proteins are also used in vaccine development and in testing as well. So we come back on that later as well. So what is the RNA actually of the virus? So as I said earlier, it is the building plan of the virus. So when it enters the cell, it says, you have to build me. And I'm built like this. I have spike proteins. I have a membrane. I have this and that. So, and then the cell knows, okay, I have to copy this and this. And then it more or less gets hijacked by the virus. So we see that it has some proteins and RNA structures to do this. Okay, so we saw that it originated in China. This is a little bit debatable, and an increase of activities during the New Year led to the rapid spread. The Chinese New Year led to the rapid spread of the virus. Chinese scientists were pretty quick with this virus. For example, they used bioinformatics, so computers, to analyze this mRNA. So to put it in the computer instead of the code of the RNA. So in that way, we could quickly move on and find out what the structure is of the RNA, of these proteins of the virus, how that virus looks like. And this was an important step, for example, in vaccine development, something we did not have access to 10 or 20 years ago. So this is why maybe the vaccine developed this quickly. So we see that the virus is actually an envelope virus, the coronavirus, which means that it is very susceptible to acids, heat, and drying and detergents. And this is why washing your hands, sterilizing things with alcohol sometimes is very beneficial. So this virus, coronavirus, must stay wet, and it cannot spread in the gastrointestinal tract, and spreads in large droplets. And that's important to know. So what is the disease cause? So most of the time, as I said earlier, you have this incubation period where you don't show any symptoms, but you may be already contagious. So you see that this virus is going to, within 5 to 10 days, it's going to start incubation period, whereafter you will notice the inflammatory phase, and some people this will become the recovery phase afterwards, whereafter, and some people will get more severe symptoms. So in some people who are immunocompromised, or people with bad luck, for example, mutations in their own genetics, which lead to overreaction of your immune system. This can lead to other problems, such as hypoxia or inflammation of the lungs, which can be fatal as well. I will move on to that in later this slide. So we also saw that, you may have heard on the news, that coronavirus is mutating over the past few weeks. And mutation is a completely normal thing, actually. That happens in all viruses, as I said earlier, because of the small mistakes cells make. There's some mistakes in there, or some changes in the structural proteins on the outside. But we see that this strain of coronavirus, G614, is going to dominate now. And this strain, these structural proteins on the outside, so the keys, they change a little bit. But because they change a little bit, the vaccine can still be effective. So that's not something to be concerned about a lot. So we see that this virus transmits through large droplets as well. As we see, this is why the social distancing part is quite important. And it can also transmit through the formaldehyde route, and that is by touching things. Everything you touch can be contaminated, and that's why it is important not to touch your face or any other things. Also, there's some research going on at the moment whether coronavirus can spread through feces and through the toilet route, more or less. We know that coronavirus is present in your feces when you are infected, and this can, for example, be seen in sewage control. Many governments are employing sewage control to measure the amount of virus particles, or the number of virus particles in the sewage at the moment. So moving on, we saw that the virus enters through these keyholes, as we said earlier. Then they start to hijack the cell, and then they start to copy themselves and get out of the cell. We see that there are some drugs, remdesivir and hydrochloroquine, for example, can block the replication of the cell of the virus. This replication will cease, and then the virus will not be released anymore, for example. So as I said earlier, coronavirus can quite be fatal for some people, unlucky people, people with compromised immune system, or simply young people with mutations or an overreaction, or with any underlying conditions, as for example, as well. We see that coronavirus, when it enters the lung, in some people, they may infect cells in the lung over here, and this can cause severe problems because our immune cells, they want to get rid of that virus. What are they going to do? They're going to kill the cells in the alveoli or in the lung. And when that happens, of course, you get scarring tissue in your lung, because your lung has specialized cells which can expand nicely as well. You get a lot of scarring tissue as well. And when that happens, you get problems with breathing. And this is, unfortunately, this is irreversible. You get problems with breathing because your lung cannot expand well enough anymore. So that's important to know for the scarring part of caused by coronavirus. And this is why some people, they also need to be put on ventilators, because they cannot get enough oxygen anymore, because lungs are not able to absorb this anymore. So there needs to be an extra ventilators. And ventilators, they have the risk that if you put yourself on a ventilator, of course, this ventilator is going to expand, pump air into your lungs, right? And this may cause some other problems. For example, problems in your breathing, and this can cause damage to your lungs even more. So what about the vaccines? We know that Oxford AstraZeneca is working on a non-replicating viral vector. So they basically put a weak virus in your body, and then your body can recognize it, and your body can, if it encounters the real coronavirus or the real deal, it's going to be able to combat that. And we also see the Pfizer Moderna vaccine, which is an mRNA vaccine, which is an RNA vaccine, which basically is an instruction, but this instruction only contains the keys of the coronavirus. So as you see, only the purple and blue spikes over there contains only that part. So it enters the cell, says you have to make these spike proteins, these keys, and then the cell can, then your body can recognize, your immune system can recognize these. And if it encounters the real coronavirus, it is able to fight that off. So how does testing work? So we see that there's PCR, or polymerase chain reaction. It sounds very complicated. The concept is quite simple, actually. So you take a swab, and if you're infected, it contains a little part of the RNA of the virus, or the virus itself. And this is put in a liquid, and this liquid conserves this virus, keeps it alive more or less. So then, and it keeps the RNA from degrading. And then it is going to put in a machine with some other complicated enzymes, and it's going to be amplified. It's going to be copied, this RNA. And if you're positive, the virus, they can, this more or less lights up. They can put some kind of probes or some light proteins which can light up if there is a virus, or if there's that particular sequence of that virus, that part of that virus present. And that's how they detect coronavirus infections. So there's also other tests, there's antibody tests, but these tests only, for example, show that if you were infected in the past with coronavirus. So if you were infected, you probably have antibodies in your body, and these antibodies can be found in your blood, but it does not show whether you still have coronavirus or not. So that's important to remember. It only shows when you were infected, whereas the PCR shows whether you were infected as well within those 14-day periods. So what is about flattening the curve and heightening the line? So the problem right now is that if there are too many people who get infected with coronavirus, and these people, for example, like people with compromised immune systems or people with other problems, they may, for example, cause the healthcare system to be overwhelmed with patients at the IC, at the intensive care, for example. And this is why we want to do all these measures to spread out all the infections and to reduce them, for example. And also heightening the capacity, for example, getting more healthcare workers in there to help out at the intensive care and making sure they don't get sick. If they get sick, of course, that line is going to go down this line, and then you get even less space to help people with problems, for example. So there's some drugs over here, as I mentioned. Remdesivir, for example, is a drug which is authorized for emergency use, for example, to alleviate the symptoms in case of severe coronavirus infections. Hydrochloroquine, we may have heard of some politicians who take this, for example, and claim that it works. However, there's off-label use has been discouraged in Netherlands and several other countries because it has some severe side effects as well. So what do we know about the 2 meter or 1.5 meter rule? That rule is actually outdated, and this is why we see a huge spike in coronavirus infections. And this is rule many countries thought that this was the silver bullet to coronavirus itself, but it is not, because there's a lot of other measures we need to take. As we see, if someone sneezes, this can travel up to 7 to 8 meters, and it also depends on the airflow of the room. So this 2 meter rule can reduce your risk, or 1.5 meter, depending on which country you live, can reduce your risk of getting infected with coronavirus, but it is not a silver bullet to the problem. So what can you do actually? Wash your hands and make sure, because coronavirus can stick to every object you touch. So make sure you wash your hands and also clean the things you touch mostly, like phones and other things. So how to reduce your risk of infection? Wear your mask, clean your hands, and avoid close contact with people, and avoid touching your eyes, nose, and mouth. So we may have heard of this ghostly light in some countries, which are UVC lights actually, and there were some politicians as well which can claim that that this lamp can be hung into a shopping mall, and then people would be free of coronavirus. Well, that's too good to be true actually. So the World Health Organization says that these UV lamps or UVC lamps should not be used to sterilize hands or skin at all, because they can be carcinogenic as well. They can cause cancer. So these lamps, when they are turned on, you have to leave the room, of course. They cannot penetrate through glass, and they more or less disinfect. They disinfect the whole room. They kill viruses, bacteria, and other organisms. You have to put them like 30 minutes. It will kill the viruses. And we see in the Netherlands, for example, at our university hospital, we have started to use them in Maastricht to sterilize PPE, like masks and other things. You've put them like 2 times 30 minutes in there. Both sides, just to get them exposed to masks, and then they can be reused, because there was a shortage of PPE in the Netherlands, and this is an emergency procedure, so it is not something we recommend to you. So what I talked about DNA earlier, so when this UV light shines at the DNA, it has a lot of energy, so it actually breaks down all the bonds between the DNA and RNA. And this can cause some problems in these organisms. And that's why I said it's dangerous for humans to be in a room with that kind of light. And because it can cause cancer. But in bacteria and viruses, they are much smaller and they're more susceptible to that light, for example. So if you turn on that light, their whole genome or DNA or RNA gets destroyed. And this will lead them to be unfunctional, and they cannot replicate, they cannot do anything anymore. basically that. So what was with the mask? So in some countries, we saw that many countries said that masks were ineffective in the beginning. And why is that actually? So some countries, they employed clinical trials and they looked at a fraction of the papers. If you of the scientific papers or scientific literature, as we see here, they looked only at the middle part, whilst there are more papers of material science, physics, and other things which prove the effectiveness of masks. So that is what happened, and why many countries in the beginning said masks are not effective, whilst they indeed are. There's a new paper or scientific paper which shows that wearing masks is actually effective and reduces the risk of coronavirus infections. So we see in the first column over there, we see a low occupancy and a second high occupancy. And we see that, for example, in the two upper columns over there, that wearing masks, for example, reduces the risk. We see that most of them are green, whilst if you don't wear mask and you're in a poorly ventilated one, it's obviously red. And if there's no face coverings at all, we see them all red. And that is why face coverings reduce the risk, because they reduce the spread of aerosols, for example, and they also protect you as a wearer. So we see that it does not matter what material, it does matter what material you wear. So it is important that you wear, for example, cotton and or any other mask. But the most important part is that you wear it correctly, the mask. So no gap. And of course, making sure it sticks right on your face, covers your nose and mouth, no gap at all. So we see that filtration efficiency, for example, will decrease if there's a gap to maybe 50% or even lower. How about public health measures, for example? We see that a lot of countries, they don't have experience with coronavirus or any pandemic, and they aren't very well equipped to communicate or communicate with the public what coronavirus is, what you need to do. There was a lot of problems, for example, in the Netherlands with face masks in the beginnings, saying that they don't work, and then there was then they came back, yes, it works, and people didn't take it seriously. So what is important is that a clear communication of what the general public should do is important. So we see in the UK, for example, that it shows that wearing a mask can make the shop safer, but it does not focus on protecting yourself as well. And we see that this woman is only wearing a scarf, and that's the least effective covering as well. So it only focuses on the older, vulnerable group. So it is important to involve everyone and to campaign and make sure that everyone is on the same page and knows what we have to deal with. In this way, we can combat, for example, conspiracy theories and fake news. And that is what many governments are falling short of, the communication parts. That's what we saw. So what is important to mention is coronavirus masks. These masks they protect the wearer as well. And social behavioral factors are important to understanding. We see that clear communication is very effective when we see that in countries with low infections, for example, these they have a much lower infection rate or not at all. So the public messaging is also important as well. So these were my resources, and this was my presentation. Just one more time to reiterate, this presentation was for information purposes only. It is not a substitute for medical diagnosis or treatment. So if you have any problems or if there's anything going wrong, please contact your doctor or call 911 if there's an emergency. So thank you. And if you're interested in our programs at our university, of course, you can also always look at our website, for example, biomedical sciences or public health, which are the programs which are very involved in coronavirus. So follow us on social media as well, and thank you. If there are any questions.
Yes, thank you so much, Kingson, for your very elaborate presentation. Yes, so we've come to the Q&A session, so I will put it as the Q&A mode. I see here in the chat box, there's one question from Theodora. She would like to know more about your experience during your studies. So, hi, Kingson. I intend to apply for biomedical sciences master. To be exact, is the intake for September 21st. I've got two questions for you. First one, will students be able to work in the lab amidst the COVID-19 situation? And second, do you get scholarship support for your study? If yes, which? Thanks.
Okay, so hello Theodora. It's nice that you're interested in our biomedical science program. So students are most of the time able to work in the lab, although with some restrictions. So when I worked in the lab pre-COVID, most of the time there were like 10 to 15 students in the lab, and now they cut that down to only 5 students in the lab. And of course, safety measures have to be taken. So you have to wash your hands, wear a mask when you enter. You have to wear gloves when you use some common equipment such as pipettes. So you will be able to work in the lab, although it will be a little bit inconvenient. I think in September, if the COVID restrictions are in place, there will be some, of course, some lab restrictions. If they're not, then everything will be returned to normal. So most of the time we'll be able to work in the lab. How about scholarships? I don't get any scholarships, but I think you can check out some scholarships on the NASA website. I think there's an Orange Tulip scholarship, but I think Amy knows more about that.
Yeah.
So I hope that answers your question, Theodora.
Let me add that for scholarships, we at our own university, we do have some options as well, but they are indeed a bit limited. I will send the link in the Q&A box from our own website as well, because we have a bit more options for master scholarships than we have for bachelors, but definitely also check with the NASO Indonesia office.
Okay. So just to add for the scholarship question, we do have scholarship for international students, especially for master students. You'll be applicable to apply Holland Scholarship. So Holland Scholarship is a partial scholarship where you will receive a 5,000 euros in the form of a tuition fee waiver. So this is for your study only. Other than that, we also have Orange Tulip Scholarship. This is also a partial scholarship, but I'm not really sure if Maastricht University is also part of Orange Tulip Scholarship for the next academic year, but I believe for the program study biomedical and sciences is not part of this scheme for next year. So I'm suggesting you to search for the to see more information that Lian just mentioned in the chat box, to see if there's other scholarships available for the master program. So that's you can visit their website. And yes, so my colleague is also just shared with you a link to our Orange Tulip Scholarship scheme for the academic year of 2020 and 2021. So you can check if biomedical sciences is part of the scheme for next year. All right. Thank you, Theodora, for your questions, and I hope that answered your question. So we still have some time left for the Q&A session. So if those who has still questions for Kingson's and as well as Lian, please feel free to write your questions in the chat box so we can discuss it now. All right. While waiting, I think I also have questions for you, Kingson. I'm just I'm actually I was curious about because you've mentioned before about the UV lamps, right? That it's not actually have nothing to do with preventing the virus from let's say from hands or anything else. But I've seen here a lot of for example, restaurants, they use those kind of like a box thingy where they put a UV lamp for their like fork, spoon, something like that.
In that case, it is effective. In that case, it is effective. So, if it's for a room or for a certain object where you expose the object to the light, in that case, it can cause the viruses and bacteria on that object. But it's not meant for humans. So, I've seen some people who buy these lights and they start doing this at home with the lights. That's definitely not what you want to do, of course, and you will get burned.
Okay, so it's more for a thing, for tools or something like that, not for humans.
I've seen in Singapore, for example, they use these lights, some robots. These robots, they drive around the shopping mall during the night when there's no one, and this will kill, for example, all the viruses and bacteria.
Yes. Okay.
Yes.
All right. Thank you, Kingson, for the answer. Yeah, because I was just curious about that, if that actually works for to reduce the bacteria or the virus.
It does work, but many people don't know that you need to put it for like 15 to 30 minutes. So they think, oh, 1 second, done. But that's definitely not what you want to do. Also, some people, they buy these lamps and they put them in the bathroom when they shower. So they turn them on when they shower. That's also not what you want to do, because then you get burned. And then your plants also die if you have any plants around. So get them out.
Okay, good to know. Good to know.
Yes.
Okay, let's see if there's other questions. Not yet. Oh, I see here Theodora is typing now. Maybe she would like to ask other questions. Okay. But I was wondering also, do you have specific courses or like a lab or something that discussing this type of virus?
Yes, so we had a whole course on viruses and bacteria, and we also had some practicals in the past. So we did do the PCR one, the PCR, the polymerase chain reaction, what they're now using to identify whether you are or were infected with the virus. That kind of test we conducted before. So that's how I know I got more or less hands-on experience. And that's what I like most about Maastricht University as well. Because other universities, they don't spend a lot of time discussing this. And I think if you study biomedical sciences and want to become a scientist, that is very important to know as well, to know about some of the uptrends.
Okay, great. So you have a lot of hands-on experience, during your lab.
Yes, and we meet with professors like every 2 days. So we research something and then we come back and discuss that with them, and that's what I also like as well. Because if you if you're not completely correct on something, they immediately correct you, saying that's maybe not the right thing you need to say, or point you in the right direction, something like that. That's what I like.
So do you get a chance to go, let's say, well, maybe before the pandemic, but to go to the hospital or something to work with real doctors or?
We don't get to do that yet. That's part of the internship phase. So I was planning to do my internship, but everyone cancelled. So I was planning to do my internship in the lab, but obviously because of the pandemic now, these labs are all full with COVID tests. And they of course, they don't want to spend time, for example, educating other people whilst they're busy with doing those things. And that's why provisionally it's cancelled.
Yeah. Okay.
Yes.
We have a question here from Theodora again. So her question is there a possibility that the stricter lockdown affects students' admission? So less student accepted, maybe?
As far as I know,
Maybe.
it does not affect your admission to the university. It does affect maybe your mobility, maybe you can't travel or due to travel restrictions. But if that's the case, our university will be very lenient in that regard. So they will make a lot of exceptions. For example, biomedical sciences, there's a lot of students who are in other European countries and they don't want to come to the Netherlands just for a practical, you know. So most of the time, the university will come up with solutions like you can do it later, the lab practical, or you can follow courses completely online, and you can still pass your course. But so that's nothing to worry about, Theodora.
Okay.
Yeah, unless it's a selective program or it has like a numerous fixes where there's a limited amount of places, we don't have any other reasons to admit fewer students. Of course, we want to make sure that everybody is safe so that we don't have too many people somewhere at once, but that's something that we handle internally. So we also still encourage everybody to, if possible, come to Maastricht and still, get started over here. So in general, we don't. We also see from this year that in the end, student numbers didn't go down, and we even grew a little bit even throughout this year. So we hope to continue that kind of development in the coming years, regardless of what happens.
Okay. Thank you, Kingson and Lian, for the answer. Hope that answered your question, Theodora. So actually also I'm curious that because I've heard that in the Netherlands there's some news that vaccine will be distributed in January, if I'm not mistaken, in the early January. So my question is, in your opinion, Kingson, do you think that's actually how do you say that, a bit too ambitious to have it like in January, or do you think, yeah, I think it should be
I think it all depends on how the government is going to handle it. So right now, the vaccines, I know the Pfizer Moderna vaccine is currently under regulation. So it's still under regulatory control by the European Medicines Agency, which is a central agency in Europe which looks at these vaccines. They expect that it will be this week or next week they will get approved. So then the rollout will start. Probably will start in January with vaccinating or in February, but they aren't really sure about that yet. So it will take a while for things to return to normal.
Yeah, we hope that the vaccine is will be, I mean, it's still in the development process, right? So just hope for the best.
Yes.
We'll see if we have other questions. We still have 3 minutes left till the event ends, before I close the event. If there's no more questions, I will share a survey. Yeah, I don't think there's more questions. So, well, thank you very much, Kingson and Lian, for being here, for participating in this event, and thank you for answering for all of the questions. I'm going to share the survey for the participant to fill in. This survey is about your expectation of the event and for the next upcoming event that we organize. So we will be very happy to receive your suggestions or inputs. Okay. We'll give a few seconds to fill in. All right. I think that should be fine. I'll receive some answer for the survey. So again, thank you very much, everyone, for joining this event. Because this is the last event for this year. So on behalf of Nuvik Neso Indonesia, we'd like to wish you all happy holidays and happy Christmas, Christmas and Happy New Year for those who are celebrating. So we will see you again in the next event in 2021. Thank you, everyone. Bye-bye.